Hi guys. So today I want to talk about one of the advanced and secure networking project that I did long time ago. Although it was not recorded on YouTube, but it's there on the website. Yeah. So it's always here on the website. So if you go to our website, gurutechnetworks.com, then you click under projects, download projects, then you go under advanced and secure networking projects. So I just want to talk about this project, which is secure university college network system design and implementation. So if you want this project, you can just download it here. So if you click download, you will be redirected to PayPal, where you make some small payment. Then you download a zip file having all these files. Okay, right. So this project actually, it has a documentation. It says a step-by-step documentation instruction on whatever has been implemented. So I just want to talk about this project a little bit. So if you look at this project, this is a very advanced project that you can use for your final year degree program, or maybe if you are doing some masters, you can use this to present as one of the assessment or at the end of the semester, yeah, but not a final project for master student. Okay. So if you look at this project, it entails two campuses. So we have a main campus on the left, okay? Then we have a branch campus on the right, okay? So the two campuses are connected via public ISPs, okay, which are providing internet access. So we have firewall in each site connecting to ISP router, okay? And interestingly, in each firewall, we've implemented IPsec, site-to-site IPsec VPN, okay? That's a communication between the two sites. So let's get down in every site. So let's start from the lower level, okay? From the bottom, I mean, okay? Right. Okay, so you can see we have several blocks. We have block A, block B, and block C. And each block, we have departments. And each department, we have designated a VLAN number, okay? And we have number of users. We have designated the IPv4 address as well as IPv6 addresses, okay? And you can just see the connection between the layer 2 switches, the access switches. We have LSCP implemented, okay, to provide redundancy, okay? As well, we have access points to provide wireless connection to our mobile users and iPhones, iPads, laptops, etc., okay? So at the departmental level, we've implemented a lot of things. One of them is the wireless devices, okay, access points, okay, you can see them. Then we have switches. These switches have been configured with VLANs. So these two switches are in VLAN 10, these two VLAN 20, etc., okay? So these switches as well have a basic configuration configured, okay? So in that regard, that will take me to our documentation. So we have a documentation here. So if you choose to download the file, you get a zipped file, okay? So the zipped file contains the screenshot of our project, okay? And then we have the packet tracer version, a complete one, the working one. Then we have some instruction before you start using this file. Okay, very important that you have to go through. Then finally, we have a documentation. So if you check on this documentation, actually I implemented this thing 2 years ago, 2023. Okay, all right. So this is the table of content. These are the step-by-step instruction on how to implement this project. Everything that is important in this project. Okay. So regarding redundancy and scalability, regarding security of the network, then we have maybe network protocol and design, device choice and naming convention. Very basic and very important in every project that you'd like to do. Then we have things like IPv6, IP addressing table. Okay, everything included in this project, every IP address used in this project is on this table. Okay, this table is here, very important. Then the configuration part. At one point you'd like to know whatever has been configured here, or you'd like to explain to some others. Maybe if you want to present this project to maybe your examiner, you want to explain step by step. So that's as well included in our documentation. So I even included a command there. So you just go to any device. Okay, so let's just assume it's just layer 3 switch. Okay, then because maybe I've forgotten the password, but the password is in the documentation. So if you forgot the password or if it's not working in your case, just go to config and click any interface, then go back to CLI and paste that one. Do show start. Okay, you see everything. This is the host name. This is our enable password. Okay, and you can see the enabled password has been encrypted with the command there. Okay, all right. So provided that this is layer 3 switch, by default we have to include this commands here for IPv4 routing and IPv6 routing. Okay, then we have configured username and password for SSH login, right? Okay, so SSH configuration are here. Okay, then we have EtherChannel. So you can see we've configured EtherChannel here between this switch and this switch, such that we've aggregated or bundled these 3 physical links into one logical channel. Okay, right. So those are there. We've configured layer 3 ports interfaces on the multi-layer switches. Okay, so you can see. Okay, these are part of EtherChannel configuration. All right, so that's very important. Then I scroll down as well. You can see trunk interfaces. Any interface connecting switch to switch should be trunk, right? Okay, so I scroll down. Yeah, you can see sub interfaces. Okay, SVIs. Okay, switch virtual interfaces. Okay, so because we are implementing, this is a layer 3 switch, so we implement what's called SVIs, switch virtual interfaces. Okay, type of VLAN, type of inter-VLAN routing. Okay, so besides that, we have implemented what's called HSRP. Okay, we have implemented what's called HSRP in each multi-layer switch. Okay, and then yeah, applies to all the SVIs. So the SVIs actually will be acting as a default gateway for each respective VLAN. So all the devices in VLAN 60 will report to this guy here. All the devices in VLAN 50 report to this guy here as their default gateway and the facilitator of all communication. Okay, all right. Then, interestingly, we have OSPF. You know, OSPF is a standard routing protocol. So we've used it here. Okay. So we've used OSPF for IPv4 and OSPF for IPv6. Okay. All right. So yeah. So line console 0 as well has password. That's why we were not able to log in directly. Okay. The VTY interfaces. Okay. As well for SSH login as some parameters set. Okay. All right. So let's go back to our documentation again. Then the second factor that we need to consider is the VLAN. So I just mentioned everything here, but for VLAN configuration, you can either choose the multi-layer switch or the access layer switch. So provided that I'm still in this multi-layer switch, let me just click it and say do show VLAN. Pretty much simple. And you can see the VLAN configuration, the VLAN that you've configured there. Okay. Okay. Then inter-VLAN routing. Pretty much simple. Inter-VLAN routing facilitates communication between devices from different VLANs. So I already shown you that. So inter-VLAN routing was configured here. You see the SVIs, switch virtual interfaces. Okay. Then another thing that you can show is EtherChannel. Okay. So EtherChannel, like I mentioned, it bundles multiple physical links into one logical channel. So just say do show EtherChannel. Oops, maybe I'm missing that command. Do show EtherChannel. It should be one word, not. This one should not be here. Okay. Yeah. So on that switch, we can see the EtherChannel should be formed between this switch and this switch. Okay. So we should only have one group. Okay. So there is one group, and we're using LACP, Link Aggregation Control Protocol. Okay. And how many ports are here? Ports number 3 ports. Okay. Okay. And maybe another command that you can use there is show EtherChannel port channel as well. You can even use that command there. Okay. So do show. Okay. Do show EtherChannel port channel. Yeah, you can see more information about that. Okay, right. So another important factor in my documentation is HSRP. Wow, a very important aspect on configuration. The HSRP as well has been configured on the multi-layer switch. So here it is. You see the standby configuration. Okay. So for HSRP, remember communication are coming from these down devices, going to the access switches, then either of these switches. So we have to make one of these switches to be primary and another one to be secondary. So for example, we have how many VLANs here? 1, 2, 3. Okay. So we can make this one to be primary of VLAN 10, but this one to be secondary of VLAN 10. Then we make this one to be primary of VLAN 20 and make this one secondary of VLAN 20. Okay. Yes. So that maybe we try to load balance traffic between these switches. Okay. Note that we only make this one primary and all traffic goes here, such that when this one fails, then this one picks up. No, that's not, we are not going to fully utilize this device. So we just have to ensure that equal traffic goes here and here. Okay, so if either fails, another one will fail take over. Okay, all right. So how do we check the either channel configuration? So the same configuration, you see the standby 30 IP, that one, okay, has been configured on this other side. So one side is primary, another one is secondary. Okay, a side with that has been configured with high IP address becomes the primary. So let me just see this side. Do show start. Okay. Yes. Okay. So you can see for VLAN 10 we have that one, standby 10, but on this side as well we should have standby 10. Okay. All right. So if I can just say this command, do show standby brief on either of the switches. Do show standby brief. Yes, you can see which one is standby and which one is active. All right. Yeah, it's pretty much simple. So we can see that this standby. No. I mean, under standby, it's local. So this switch is standby for VLAN 10. Okay. Okay, but it is active or the primary one for VLAN 20. Okay, it is standby for VLAN 30. Okay, but primary or active for VLAN 50. All right. So let's see another information here. Server farm. So we have a server farm here, or what we call a DMZ zone. So the DMZ zone contains our servers. So we have a web server here, FTP server, TFTP, SMTP, DB server, a DHCP. Okay. So these web servers actually they do have static IP address configuration. Okay, because we cannot have a dynamic IP address allocation for our servers. So for all these clients, they should have dynamic IP address allocation, okay? But for servers, static, okay? And then this is the DHCP server. So we can just go into the DHCP server, go to services, so that we see the DHCP pools that have been configured for the departments. Yeah, so we have these pools. So if you click on this pool, it's the staff pool. So I don't know whether we have any department called staff here. Let me see on this side. Yeah, staff. Yeah. So it has pools for every department. We have student, we have IT, sales, HR, etc. Okay. All right. So another important thing on the documentation, I think it's DHCP configuration. Yeah, I've just shown you that. And then the evidence of automatic IP address allocation. So you can just go to any host here. For example, this smartphone. Come to desktop, then IP configuration. You can see everything is dynamic, both IPv6 and IPv4. So if I can just go back here and go back to DHCP, let's wait and see what's happening. Yep, DHCP request successful. What about IPv6? Let's see. Good. Yeah. So everything is working fine. And then IPv6 and Slack. Wow. So we can just show that via standard config. Yes. Just show start. Do show start. Do show start. You can see the IPv6 configuration on the sub interfaces, on the SVIs. Okay, so you can see this configuration there. Okay. Yep. So that's pretty much simple. That's how we configure our sub interfaces to have IPv6 addresses. Okay. Another important thing is OSPF. So OSPF, you can see, is the routing protocol. You can either check it on the multi-layer switches, the firewall, or all these routers. Okay. So let me just proceed with the firewall, and fortunately, here it is for IPv4 and for IPv6. Another important thing here is default static route. So the default static route, I think this was configured in the firewall, because the firewall actually connects us to the internet. So we need to tell the firewall that forward all traffic to the internet. Okay. So for that one, you can just go here. Show start. Yeah. So we should have where is it? We should have a static route somewhere here. My growing hold. Let me see. Yeah. Where can I see the routes? Okay. I don't understand why this lacks that configuration, or maybe I don't see it properly. Let me see this one. Show start. Yeah, here it is. Yeah, so there's a route. I think for this one, OSPF is doing everything. There's no problem because OSPF, I've configured OSPF here on this router, so there's no problem. But we should configure a static route there for a good practice. Okay, so here's the static route. Okay, then we have Cisco ASA firewall configuration, the most interesting part. Okay, so we have a firewall here. So this firewall, the firewall is divided in 3 zones. So we have inside zone, okay, where our users are. Then we have the DMZ, where our servers are. Then we have outside the internet. So the inside zone is trusted zone. Okay, 100%. We trust our inside users. Okay, server zone, server farm is partially trusted because the internet users can directly reach to our server farm, but we don't trust these guys here, the internet users. Okay, so just for some maybe some information, just say show start. Yeah, so for the firewall, you don't use do show, just say show. Okay, so you can see for gig for that interface, the name has been configured as outside zone. Okay, we give it a security level of 0 because we don't trust it. Then we assign it IP address. That is this interface. Okay, the one that connects to the ISP. Okay, this one. Okay, then we have this one. So we have 2 insides because you can see the firewall is connected to 2 multi-layer switches. So we have gig 1 2 and gig 1 3. So we name them inside 1 and inside 2. We give them security level of 100%. We trust them. Then we have this interface here, the one connecting to our servers farm. You can see we named it as DMZ. Security level 70. We partially trust it. Okay. Then we give it some IP address. Okay. All right. So another thing that we've configured on the firewall is NAT. As you know that NAT do translates a private IP address into public IP address and vice versa. Okay. Then we've configured what's called access control list. So because this is a firewall on a packet tracer, we don't have the geo height to maybe do some high level configuration. Okay, so we just use access control list to restrict access to and fro. So for example, whenever you want to restrict traffic from inside to outside, you use a kind of access control list, okay? And maybe you name it traffic going from inside to outside, okay? Then you specify protocol that you want to permit, okay? Okay, so the same applies when you want to specify traffic going from inside to the DMZ, okay? All right, so then you put you effect the access control list to each interface, okay? So access control list group, this one, to be effected on which interface? The DMZ interface. The other one to be effected on the outside interface. So that's how you do it, okay? All right, so another thing that we configured there, I think it's, let me see. Yeah, OSPF, as I mentioned, it's here. Okay. All right, let me see anything that's remaining here. Wireless configuration. So access points are pretty much simple configure. You just go here, you just go to config, choose that one. Okay, port 1. You put the SSID, you make the password, then you go to each individual wireless device, then wireless 0, you go to config, then wireless 0, you just make the SSID and the password. Okay, yeah, pretty much simple. Finally, we have testing communication. Very important thing, very important part of this lab. So the purpose of this project is to ensure that users from this side are able to communicate with guys from this side, and guys from this side are able to obtain IP address from these servers here, because in this branch campus we do not have a server farm. Okay, all these devices get the IP address from our main campus. So let's test that first. We just want to ensure that these guys get the IP address from our data center. It takes some time. Yeah, there it is. All right. So let's just take note of that IP address. It is okay. Let me just go here and say IP config. Here's the IP address. Okay. I just copy it. Then I go to any random one. Let me just even choose this computer here. Okay. And let me first check. Yes, it has IP address. Then if you go to command prompt and say IP config, yeah, you can see it has this IP address. So let's try to ping. Yes. Yeah. So the first packet might always fail. The first, second, but the third one, the subsequent one might go through. Okay, let's just see whether the communication is okay. Yeah, so this is indeed a very long path. Yeah, there it is. Yeah, there it is. So we have 50% loss. If we test it again, the first loss are due to our ARP. Okay, so if we test it again, yeah, now it should be 100%. So the first test, you should always see some losses due to what we call ARP, because this guy has to establish where the other guy is, and this thing has what is called TTL, time to live. So in the process of this guy establishing where this guy is, the TTL is expiring. So that's why we can see that the first test, we normally see timeout. Okay? But if you repeat the test again, now it's 100%. Okay? All right. So guys, this is a very important project. If you need it, if you want it, it has everything that project should have. If you want it, just go to our website. I'll leave a link on the description part of the video. Click on the link and download this project. So the project contains complete Cisco Packet Tracer, the one that we've just tested, a complete documentation, the one that I've just shown you here. Okay. IP addressing table is inside that documentation. We have case study. The case study is just here. You don't need to get it. It's here. You can just copy it and paste it somewhere. Okay. Then project screenshot. I think I showed you that. Okay. All right. So thank you guys. I hope to see you getting this project. All right. Thank you. Have a good day. Bye bye.